Get started. Hey, everybody. My name is Stephen Feuerstein, and I'm the Oracle Developer Advocate for PL SQL, and I'm part of a team. In theory, I manage the team of advocates, including Chris Saxon. Hopefully, you've caught some of his SQL magic acts at the conference. They've been a lot of fun. And Blaine Carter, who did a great talk on IoT and open source tooling with Oracle Database. And our job is to help current users utilize Oracle Database more effectively, specifically for application development, and also to convince all those JavaScript developers that they just don't know what they're missing. And they should really get a hold of PL SQL and run with it. Email, Twitter, blog, YouTube. Feel free to get in touch afterwards. Follow me on Twitter so I can get my numbers up even higher than they already are, and they're pretty astronomical, I must say. Because it is a numbers game out there in the world of social media. So what I'm going to do is talk today about impact analysis with PL Scope. PL Scope is a feature that was first introduced in 11G, and it was enhanced really nicely in 12.2. And it helps you do impact analysis on your code. Don't forget to fill out your evaluations and come to the party tonight. Some resources for Oracle database developers. I agree very much with Bryn that there's no such thing as a PL SQL developer. You never write PL SQL all by itself. You're always at least writing SQL and PL SQL, and you're building applications on top of Oracle Database. So, the official home of PL SQL, oracle.com/PL SQL, which will of course lead you to many other resources, documentation, learn more, lots of stuff. So go visit, check it out. In addition, SQL PL SQL discussion forum. How many of you are active on that answering questions? Asking questions? Going to Stack Exchange and Stack Overflow instead? Never having any questions you need answered? All right, all right. We know our stuff, because we've been doing it for like 100 years. Bryn Llewellyn, PL SQL Product Manager and EBR Product Manager, sitting in the second row in the middle. He has a blog. It is a go-to blog for anybody who's doing work on PL SQL and addition-based redefinition. So if you haven't gone there to check it out, do so. I have a blog too, and I post, well, I haven't been posting too much lately, but a lot of little stuff, and you know, you can take it or leave it, but when he posts something, you gotta read it.
I'm going for quality, not frequency.
That's right. And these days I'm going for neither, it looks like. Oracle Learning Library. How many of you use the Oracle Learning Library? So oracle.com/OLL, it's a repository of resources across the entire Oracle product suite, not just Oracle Database. And lots of great stuff there, including a lot of Oracle by example tutorials. There's the Dev Gym, which is a quiz platform and class platform. So we offer weekly PL SQL and SQL quizzes. And recently just finished up an introduction to databases for developers, which had about 2,700 subscribers, and people were really enjoying the very creative videos by Chris Saxon. You basically take a video, watch a video, and then you take quizzes to reinforce your knowledge about them. So check that out if you haven't been there yet. Then, of course, there's Ask Tom. I consider my finest achievement since coming back to Oracle in 2014 was hiring the two people, Chris and Connor McDonald, who stepped into Tom Kite's enormous shoes when he left on personal leave for a little while, and that turned into forever. And we brought asktom.oracle.com back to life. They're answering more questions than Tom has done for a number of years. Dan McGann, another man on my team, revamped the website, so check it out, and we'll be adding even more stuff there in the next few months. I'm not sure when we'll get it started. We'll be adding Ask Tom office hours, in which we'll have hopefully dozens of product managers, evangelists, and database experts from inside Oracle offering monthly free open Q&A sessions through Ask Tom. So you'll hopefully hear a lot more about that. Live SQL. How many of you have used Live SQL? Not bad. Okay, so Live SQL offers 24/7 access to a 12.2 database instance, and soon it'll offer 24/7 access to an 18.1 Oracle database instance. Hopefully you've all heard the big news, right? We're changing our numbering scheme. Come on, this is big. So we're going to go on a yearly cycle from now on. So we'll be releasing 18.1, I assume, sometime in 2018, and then in 2019. You get the idea. So Live SQL offers a place where you can go, and we'll be using it today to just try stuff out. Now that part of Live SQL is not particularly, of concern for you. For example, so you can come here and say, oh, I've heard about SQL. Can I do like select star from EMP? No. But how about employees? Yes. And then I don't see any output. Okay, well, that's interesting. There you go. So, if you have somebody who's new to the database and wants to just play around, you can send them here and they can try things out. There are tutorials, and there's a whole code library, essentially, behind this. So I've published about 150 scripts on PL SQL, including PL Scope, which we're going to look at today. And there are tutorials on SQL, PL SQL. In fact, 2 of the hands-on labs this week were run by Kim Berg-Hansen, who's our SQL quizmaster on the Dev Gym. He built tutorials on advanced SQL topics that people have been taking. Anybody do that this week? What'd you think? Really nice, right? So check out Live SQL. And again, I'll be showing you scripts from that today. There must be a way to just have it go back to the... Oh, well. Look at that. There we go. And a couple of websites that I have found useful over the years from non-Oracle folks, non-Oracle employees. So oracledeveloper.net by Adrian Billington. Adrian helped me out on my Oracle PL SQL programming book a bit on pipeline table functions, and has great articles on all the different features in SQL and PL SQL up through 11G release 2. Then he had too many kids, and his priorities changed. But Tim Hall, he doesn't seem to have any sort of life at all, so he keeps right up to the latest. So oraclebase.com is I think hopefully a lot of you know about and agree, is a pretty amazing place to go for examples, insights, blogs, videos. He started up a new video series. Tim is pretty remarkable, so make good use of him. So obviously, there's a lot of stuff out there to learn about these features and apply them. I know your problem is, well, finding time to do it, and finding not only time for yourselves to learn it, but finding space in a development calendar to say, hey, manager, let's put in some cool new stuff. Like, I don't think so. Seems to work okay. All right, so let's take a look at PL Scope. So you've got 25,000, 50,000 lines of code. How many of you work on a PL SQL code base of at least 25,000 lines of code? How about 50,000? 75,000? I think I still got my hand up. 100,000? Okay, so lots of code. And obviously it accretes over the years, and you keep it up to date with all the newest features, and you clean it up all the time. And then it's time to make a change. And one of the key things we have to do is get some sense of what's going to break when I make this change? What could possibly be affected? And in the past, we've offered a number of ways to do that. Some of them pretty good, some of them fairly inadequate. But PL Scope added in 11.1 offers a whole new array of tools at your disposal for examining your code and getting answers to all sorts of interesting questions about it. And the basic idea is that you turn on PL Scope, and I'll be showing you the steps behind this, obviously. And then when you compile your program units, it collects information about all your identifiers, and with 12.2, your SQL statements as well, throws them into data dictionary views, and then you can write queries against those views to get information or get answers to interesting questions. For example, find the places where variables are assigned a value in my program. So you might say to yourself, so you run some code, and the value of your variable is set to null. Like, well, it shouldn't have been set to null. In fact, it should have been declared as not null, according to Bryn's advice yesterday. But it did get set to null. Where did that happen? Now, of course, you could use the PL SQL debugger in SQL Developer. How many of you use the debugger in SQL Developer? That's a lot. That's great. And go step by step by step by step, and that's good, and it can also be tedious. You can turn on tracing. But now what you can actually say with PL Scope is find all the places where this thing could be modified and out parameter. It could be a select into, it could be an assignment. So those kinds of very fine-tuned questions can get answered. What variables are declared inside a given program, which programs call other programs. You can see the call stack down to subprogram units and trace it around. Find the type of a variable from its declaration, many, many different things. And the big news, and the reason I'm really pushing PL Scope hard now, is that with 12.2, it also analyzes your SQL statements in your PL SQL code. And that means that for the first time, you can actually answer questions like, where are all the places in my 50,000 lines of code where I do an insert into table X? And previous to this, there was no really good way to do that quickly. You could find, we'll talk about what you could do beforehand. So I'll come back to that. All the code I'll be showing you today is available at livesql.oracle.com. In addition, I have a demo zip that you can download with a bunch of my files at the PL SQL Learning Library, which is oracle.com/OLL/PL SQL. Okay, So let's talk about life without PL Scope before I talk more about what you can get done with PL Scope. So before PL Scope, at least in terms of the tools that we give you out of the box in the database, you could, roughly speaking, search text. Now you could, of course, search the text on your directory, and I do a bunch of that too, with Sublime lately. You could select from all source. You could say, find all the lines of text and all the code I have access to that has the string ABC in it. But of course, you get all sorts of interesting results from that, unless you write some really great regular expressions. And then there are things like the all dependencies data dictionary view. And that gives you dependency information. And that's great. So you can answer questions like, find all the program units that reference table X. But that's about it. And the reference could be almost anything. It could be a % row type, a % type against a column in the table. It could be a delete, an update, etc. And that was the level of granularity you had. Now, in addition, in 11.1, Oracle added support or implemented fine-grained dependencies. So even though in all dependencies you can only get down to the object level, so this table depends, this package depends on the following 16 tables, we now keep track of subunit elements. So for example, which parameters, which columns of a table are actually being used. And that information is used by us, by the PL SQL compiler, to keep track of dependencies for purposes of invalidation. So as you probably know, if you recompile a program unit, all the program units that depend on that one, that reference it, are marked invalid and have to be recompiled. And often they're just automatically recompiled for you. But there's a chain of invalidations that can happen. And prior to 11.1, if you made any change to your table, any package that referenced that table would have to be recompiled. Now it's much more fine-grained. So for example, if you add a new column into the table, well, that's not going to invalidate things because your program wasn't using that column before and it's still not going to use it, and so on, things like that. So we use that information internally. Unfortunately, you don't have access to that information. Maybe we'll make it available eventually. I don't know. No, we're not going to make it available eventually. I shouldn't even raise your expectations. Thank you, Bryn. So in general, you could write queries like this, select from the all dependencies table. I've got, I want to find the references to tables and so forth and so on. But it doesn't give you very much actionable information. By the way, so the reference to this file right here is a file inside my demo zip. But also, you could say fine-grained dependencies. That sounds interesting. Let's see. If I put in dependence, and I spell it right, fine-grained dependency management. So click on the script, and you can take a look at an example of utilizing the fine-grained dependency information, or how, and specifically, how it should affect the way you write your code. So there are things you can do as you write your code to take advantage of fine-grained dependencies to minimize invalidations. Roughly speaking, whenever you write a SQL statement inside your PL SQL code, qualify every reference. So you're already familiar with qualifying things with their table name, right, or their alias, s dot, student ID, and so forth and so on. But what you also want to do is get in the habit of, do I have an example here? Let's see. What you also want to do is qualify references to your variables, your PL SQL variables, with the name of the program unit. Oh well, I'll open up one more file and then I'll give up. Okay, so the basic idea is that when you've got select statements in your code, here I'll just give you an example from my code showing you how you shouldn't do it, because I've got lots of code that does that. Never a problem. Sorry?
That was from before when I tipped you off on this one.
So essentially, inside your SQL statements, you always want to qualify the name of the column. And also, when you reference variables from your code, you want to reference it .qualify. Now, this is .qualify because it's a record field. But in general, you can also take the name of the program unit. So set class email tags and .qualify that. And because program units and tables and views share the same namespace, you're guaranteed that they're not going to conflict. And so you're giving the compiler more information so that when you make a change to that SQL, make a change to the table underneath it, it's less likely to say this program needs to be invalidated because it's already resolved all those references to the unit at hand. Okay? So that's the basic idea. Qualify everything, and you're less likely to be invalidating program units.
It's a correctness point, Steve.
Please make that correctness point. Go ahead.
If you don't do that religiously, then the fact that you might get invalidation where you didn't think you would is not a sign that you're losing a bit of optimization. It's a sign that the meaning of your program changed because of name capture. Or I should say it's a sign that meaning could change because of name capture. And maybe you were lucky or maybe you were not this lucky. But you ought to be aware of that possibility, otherwise you risk silent on the results.
Right, so for example, if you add a column to the table that matches the name of your variable, then you've got name capture. It's actually going to treat it as the SQL column, not your PL SQL variable, right? And you can get some very interesting bugs as a result. Have you ever had that happen? I've done that. That's a pretty interesting bug.
Not that we know of.
Not that you know of, that's right. It recompiled. Okay, so getting started with PL scope. So first of all, what you want to do is execute an alter session, or you could say alter procedure. You can set this at the program unit level or at the session level, and turning on PL scope. Now this is the way a statement would look prior to 12.2. I'll show you the 12.2 enhancements a bit later. How many of you are on 12.2 now? Okay, so a few of you, that's great. But I didn't want you to think that all the PL scope features are only available once you get to 12.2. You can, as of 11.1, there's a lot you can do with PL scope, and then I'll add on the 12.2 stuff a bit later on. So you say identifiers all, you turn on gathering of identifier information, and it's off by default. And then whenever you compile a unit from that point on, it will gather that information and stuff it into the identifier's views. Then you write queries against it. Now in the world of SQL Developer, if I go and check out, open up the preferences, come on, preferences, thank you. And for any of you at the Bryn and Stevens show yesterday, I showed you the screen with compile time warnings. So here's the compile time warning settings, and these are the ones that I use. The optimization level, you should set it to 3, or you should, dare I say it, tell your DBA to set it to 3 in your database. And then set your PL SQL identifier level. Sorry, Bryn, it's been a long week, huh? And you can set it to none or all, that's it. And I set it to all. So this way, every time you connect inside SQL Developer, it'll execute the commands as shown on the screen for you, and you're all set, ready to go. If you want to see the values of a particular program unit, you can check the All PL SQL Object Settings view. So basically that has all the compile time settings for your units. And you can see which ones have PL scope turned on, which ones don't. What's the optimization level of a given program unit and not. And so you can write queries against that view to give you some QA on your code. Like make sure that I have no program units with a compilation level, an optimization level set to less than 2. You could say, do I have any program units that don't have identifiers being gathered on them? Things like that. Okay. So what I'm going to do for the rest of the talk is basically tell you a little bit about these different views, not go into an enormous amount of detail because you're not going to remember it. And at this point, for the most part, PL scope comes down to you writing queries, though I'll show you some resources that we've defined that myself and others have created to help you get started and get running with it. And hopefully there'll be more and more built into SQL Developer over time. And I'll just talk about different kinds of questions you can get answered and hopefully get you excited about the possibilities. So we keep track of the type of identifier, variable, constant, procedure, function, package, etc. What the usage is, where it's defined, where it's declared, an assignment that's been made to it. The line and column, where it appeared in your code. The signature, a unique value assigned to every individual identifier. This is really key because you might have identifiers with the same name all over the place. And you can get really confused if you search through all sorts to say, find all the strings ABC. Well, every single identifier has its own unique signature that you can use to match across program units and find those references. And then usage ID and usage context ID allow you to do essentially hierarchical views of your code. Essentially, usage context ID is parent usage ID, just like employee IDs and manager IDs. So let's take a look at some examples. Show me all the identifiers in a program unit, a basic query against the view. Show all the variables declared at the subprogram, not package level. Show all variables declared in the package specification. So one of the things you can use PL scope for are some basic QA. If you declare variables in the package spec, the specification, then any program unit, any schema that has execute authority on that program unit can muck around with that variable as much as the programmer wants to. Right? You can't trust the value in it. So in general, the best practice is move those variables out of the spec into the body and build getters and setters around them if you want to expose that individual variable or only use it internal to other program units. Show locations where the variable could be modified, essentially where assignments are being done. So let's take a look at some examples, and we'll just go to live SQL so that you know that you can come back to this anytime you want and take a look around, do the same thing. Now I would just write scope. This is what I did initially, but check it out. There are a whole lot of kscope examples in here now. Kscope 17, so I'll make it PL scope. So PL scope examples. So you come to live SQL, you sign in, you find a script you like, you can run the script, and it runs super fast. And if you see that some statements didn't run successfully, this one happens to have them all run successfully, it doesn't mean anything went wrong. Often, at least in my scripts, I have steps that raise errors that are demonstrating certain points, so don't be alarmed necessarily. So what I've done here is create a copy of the employees table from the read-only schema HR. I probably don't really need to do this since I'm creating program units with my own elements. Anyway, turn on PL scope, create some code that I can analyze. So here's an example of showing the identifiers using that hierarchy of usage ID and usage context ID. Now, in live SQL, you'll find that I'm querying from user identifiers, not to get into the details behind the scenes, but most of the all views are not available inside live SQL, only the schema-specific views, user. So in a lot of cases, you'll take these examples and change user into all, add the owner clause if you want to scan across multiple schemas for all the code you have execute authority on, not just the ones you own. I'm using the with clause, subquery factoring, which makes it easy to write really readable SQL statements. Starting at the root, doing my little L padding. I'm sure you've all done code like this before. And here we go. So I've got a package within it. I've got the definition of the package, a definition of a procedure, the declaration of a formal. That means it's a parameter. There are formal parameters and actual arguments, values passed to or coming back from the program unit. The type, it's an integer. So I've got an in, I've got all in parameters here. And this is something you get with 12.2. Here's a reference to a table column. And what that means is that what I should see is a percent type declaration. So this is part of 12.2. In 11.1 and 11.2, et cetera, you will not see this part of the results. But it's actually telling me that my data type is a table. Table.column, percent type. So then you can, of course, do the analysis based around some of those references to tables in a variety of ways. Let's keep going. Here's another one that I really like about PL scope. How many of you have naming conventions for your code? Nice. How many of you follow them pretty regularly, pretty consistently? Or think you do, at least, right? And how many of you have naming conventions for the entire group? And do you think they're followed pretty consistently? No. Who knows, right? And it's hard to, there's nothing, I don't think in SQL Developer, I don't even know about Toad, it's been a while since I've used it, that allows you to specify your naming conventions and say, check for any violations. Here's an example of how you can do that with PL scope. Let's see, I can get rid of that, get rid of that. That makes it better. So here are examples of my preferences, and obviously they're probably not yours, but that's okay. It doesn't matter what yours and mine are. The fact is, as long as you can express it in SQL. So what I like to do is employee underscore in, employee underscore out, employee underscore either in out or IO, I change my mind sometimes. So I'm looking for all the parameters. Here's the type formal in out, or formal out, and their declarations. And then I check. If it's formal in, then the parameter name, if it's not like underscore in, I've got a problem. If it's not like underscore out and it's an out parameter, and so on and so forth. So what I've done here is find out which of my declarations, which of my naming conventions were violated, or where they were violated. Okay. So as long as you can express your rules in SQL, and I'd be very surprised. Well, let's put it this way. If you have a naming convention that you can't express in a SQL statement, you might want to consider changing your naming convention. Now, here's an example of just showing you the signatures. So I'm simply getting out all the identifiers, line, name, type, usage, and the signature for each of these different elements. So it generates a unique value for each one of those elements. Find usages of variables declared with a given name. Find exceptions. Well, here are the usages of my exception. So I've declared an exception in my procedure, and I'm finding all the references to that exception in my code. And you can see the different kinds of things that will arrive. I've got a declaration, an assignment, a reference. Assignment to an exception? Have you ever done an assignment to an exception? How many of you have declared your own exceptions? And have you ever done an assignment to your exception? Well, think about it. What could that possibly be? It's accurate. It's a pragma exception init. So when you declare an exception, let's go back up to the unit. So when I declare an exception, I can also say pragma exception init, and hopefully there's one here since it did an assignment. There we go. If you don't execute the pragma or include a pragma in your code, what's the error code for your user-defined exception?
20,000.
20,000? Other thoughts on that?
There's none.
Well, if you call SQL code, it returns a value. So if you execute the SQL code function for a user-defined exception that was raised, it returns 1. 20,000 or negative 20,000, depending on your perspective on things, is part of the range of raise application error, acceptable error codes. So it's set to 1. So if you define a user-defined exception and you never give it a number, and it's raised and you say, well, we better store that SQL code so we can figure out what went wrong later, you're just going to see 1, which is not very useful. And what's
Unhandled exceptions. Unhandled user-defined exception.
You mean if it's trapped in a when others? If I call SQL code, it returns 1. No, you don't think so?
I thought you were talking about one of the scripts out of your SQL context.
Okay. And what's the error message associated with a user-defined exception without making any special effort? User-defined error. So how do you give a message? How do you associate a message with a user-defined exception? So what the pragma exception init does is associate this number with this exception. So when I can trap it by name, certainly, but if I called SQL code, it would now return minus 20,900. If I called SQL error message, it would say user-defined error. So how can I assign a user-defined, an application-specific message to that error code? When I do a raise application error, that's right. So if you need to construct your own message and raise it back out through the stack, you would call raise application error. Okay, but so that's an assignment. That's the declaration. That's an assignment. These are references. So that's what you see in the output from PL Scope. Here's a good one. And this is one of a class of the kind of things you can do in your code. This came up yesterday, actually. The question was, do compile time warnings tell me if I declare something but don't use it? And the answer is not yet, hopefully soon, or hopefully at some future 18.1 or 19.2 version, whatever it will be. Anyway, with PL Scope, you can do that today. So here's an example of a query that finds all the programs that have declared but unused exceptions. So I get all the exceptions that are declared. Here's my, again, query subfactoring with the with clause. How many of you use the with clause? Great stuff, right? Really nice. And hopefully you know that you can, in 12.1, have with function and declare your functions inside SQL statements. Probably less useful generally, but subquery factoring is really excellent. So these are all my subprograms that have an exception. These are all the programs that raise an exception, or have a reference to an exception. I guess that would be a raise or a when. So I do one minus the other. So readable, so nice. And there we go. So there's an example of how you can write your own queries that will find the things that are declared but not used. Any questions so far? Okay. Package level variables in the spec. So again, these can be real problems for you if you didn't realize it, or you have a newbie coming into work and you say, time to write PL SQL, and you should always use packages. Okay, so everything's a package, and I declare 500 variables in my package spec, and I use them in all my private subprograms. There are probably people who do this. I just thought it out, but must be done. And again, if it's declared in the package spec, that means that any program that can call that package, an element of that package, can change it. Not to be trusted. So if you need scratch pad data, if you just want something that you can call and that already exists, I want to declare a collection of a certain type, but just have it there for anybody to use whenever they want to, which is probably not a good use case for that. In any case, it's good to know when they're exposed in the package spec, and this will do it for you. Find all the variables, their declarations, inside a package, as opposed to package body. Okay. Let's see if there are other examples I didn't already show you. Nope, I showed you those too. Great. So I'm going to skip this right now because at the end of the talk I'll go over some utilities available to you. But the bottom line is that as you're getting the idea, you sit down and you write select statements to utilize all identifiers, PL scope. And I don't know about you, but that's not really ideal, is it, right? The chance that you're actually going to walk out of this room and start to use PL scope kind of plummets if you have to actually do something for yourself. I get it. We're all busy. So we need to do a lot more on our side to help you to leverage this stuff fully. And like I say, SQL Developer at some point, it has some support for PL scope, some visibility into PL scope data, but it's not that interesting yet. But I've written some reports in PL in SQL Developer I'll show you, and there are some other utilities out there both on Live SQL and beyond. I'll cover that later in the class. So let's go ahead and move on to 12.2. Now, you might be saying to yourself, time to take a snooze. We're not going to be up on 12.2 anytime soon. Why bother? So, okay, if you need to take a nap, I don't mind, really. But here's the thing. Even if you're not going to be up in any sort of production way or active development way on 12.2, you might want to take a look at the new features and see if there are features that you would like to leverage or plan to leverage, and ask yourself, how will that affect my coding right now? Often there are features that if you can anticipate that you will be utilizing, can change your style of code or what you're doing right now. And second of all, you could certainly install 12.2. You can download it as a developer day VM. You can download it from Docker. You've all gone to Docker to get your database, right? You go to GitHub and download Oracle 12.2. It's out there. It's ready for you. Anyway, what I'm saying is that you can actually install your code base on a 12.2 and run these kinds of queries and do this kind of analysis, even if your production development environment is not on 12.2. Okay, so the big news in 12.2 is that PL scope was enhanced to also include analysis or gathering of data on SQL statements in your code. And this was the kind of the gaping hole that was left open in PL scope in earlier versions. So what you do is add into your alter session or alter program unit statement, identifiers all, statements all, and you could of course say I only want SQL statements and no identifiers or vice versa, but chances are you'll just say, give it to me. So then you can now find out where specific columns are referenced, program units performing specific DML operations. Find all the SQL statements containing hints. So your developers went crazy. They learned that you could do this thing /*+, and you could tell that optimizer what to do. Darn it. And of course that can create all sorts of horrible problems. So now very easily, you can find all those references across your code base. Dynamic SQL usages. So it's true that we should be writing code that has no SQL injection vulnerabilities. But you don't write all the code in your organization, and maybe some other doofus did do that. So now it's relatively easy to write a query that says, find all, for example, find all my execute immediate statements, find all my open for statements. And these are the places where there could be vulnerabilities. And you can even extend that to query against or to check for identifiers for DBMS SQL for the older style of writing dynamic SQL. Find all the places where you do commits and rollbacks. Some people have crazy ideas like every time I issue a SQL statement, I need to commit. And they don't even understand the concept of a transaction. For example, you somehow convince the JavaScript and Java developers in your organization that they should write SQL too. I'm not sure that's a good idea. I think you should convince them to say, you need something? Do you need something from the database? Tell me. I'll give it to you really fast. Something I've been talking with a lot of people here this week. We have this constant conversation with our front-end developers. They don't want to work with the database or work with it in a really, really kind of dumb way. And I don't think they realize, and maybe we don't realize, how productive you can be as a back-end developer. For them to write some SQL and deal with the data is really kind of a pain in the neck. And they bring in ORMs and whatever else to get the job done. But if you can promise them, hey, if you need something, I'll give it to you through a nice PL SQL API or views or whatever, you can turn around the requests almost immediately, a few minutes later. What? That function's available already? So, if those people said, okay, I'll put a commit after everything because there's no such thing as a transaction, right? Anyway, you can now find those places. This was one I really like. Multiple appearances of the same SQL statement. So a lot of times we do a lot of copy pasting, or not even copy pasting. I've got one of my main tables is the employees table, and I need to get a single row from the employees table, and I do select star from employees and into record % row type, all over the place. Redundant statements that are exactly the same, or at least something you should flag and look at as possible areas to consolidate. Because the more you have those kinds of redundancies, the harder it is to optimize, the harder it is to maintain that code. We'll take a look at that in more detail. And one of the latest ones that I've been looking at is SQL statements that call user-defined functions. So select my function ... from table, and inside your function you might call another select statement that calls a function and create some really nasty problems on a number of levels. You can now use PL Scope to find all those SQL statements that call your user-defined functions. Pretty cool stuff, right? So there's a new all statements view. It's got a whole bunch of stuff in it. It'll tell you, does it do an into record, bulk collect into, does it have a for update clause, current of clause, and so on and so forth. SQL ID that points back to the SQL statement in the $find views. They did a really nice job here. So, can't get much simpler than this. Find all the SQL statements, or find my program units that have SQL statements that contain hints. That's it. Okay. Find all the DML statements in my code. Where do I have them in my code? Just in general. So here's an example of this question of find duplicate SQL statements that are the same. And I want to talk about that for a little bit. What does it mean for a SQL statement to be the same? Well, let's talk about optimization in the database. So if I execute one statement, one select statement, and then, so let's say I just started up the database instance, so it's going to parse that SQL statement, store it inside the SGA, store the pre-parsed cursor. And then every time another SQL statement is sent in to be executed, Oracle's going to check to see, do I need to hard parse that statement? How does it make that decision? Anybody know? Right, so it takes the string, the SQL string, it hashes it to a number, and it says, does anybody else have the same number? And so, and if it has the same number, that means it's the same physical SQL statement, and it avoids the hard parse. And that means that the slightest physical change in your SQL statement can cause it to hard parse. So you have a capital S, but I did a lowercase s because we have different naming conventions. Well, maybe that's true, maybe not. Let's take a look at some code. So here is a PL SQL program unit, a procedure, and it has 3 select statements in it. So I start up my database instance, I run this procedure. How many different hard parses occur? How many different distinct SQL statements do I have here? Got 2. Anybody else? 1. Cool. There's one other really acceptable answer at this point. 3. Okay, so we've got 1, 2, and 3. No zeros, no 4s. It's all good. I like it. 42. 42 is always an acceptable answer. So, Kim, why 1?
Why one? Well, basically it is on, hang on. I'll change my mind to 2.
Okay, so the general inclination for sorry?
Because of the order.
Right, okay. So generally speaking, if you know the rule for avoiding hard parsing is that your SQL statements are physically exactly the same, the first inclination is to say 3. They're all physically different. This has lowercase select, this has uppercase select, this has ename like S and department number, this has department number equal and ename like. But in fact, the answer is 2. So who said 2? Gallo, you said 2, right? Why only 2?
Because once we go from build SQL to SQL, it gets uppercase, binds, it gets replaced, it gets signed eyes, blah, blah, blah.
So one of the totally coolest things about writing SQL statements in PL SQL, a really good argument for always putting your SQL inside PL SQL, is that when PL SQL, when the compiler compiles your program in it, it canonicalizes the SQL statements, which, as Maurice just described, means that it uppercases all the keywords, it gets rid of all the additional white space, no more line breaks, just one long string. And so 2 of these statements might look different inside your code, but once they're canonicalized, they're physically the same. And this one pretty much is physically the same, except they're in the wrong order. And you might say, well, we can look at that and know that they're actually the same statement. Why can't the database?
Have I got the wrong glasses on? Isn't there a literal predicate? Yes.
A literal here? Yeah?
That's not present in the other statements, is it?
Right.
So it is what it is. It's just it's nothing to do with the order.
So you mean,
Had you put that, it would be important in a different discussion. Is that what you meant to do?
so how about that?
You mean the difference? Sorry, I can't read it. You mean the difference is
The predicates are in the difference order. Right.
nothing else? Yes.
So logically they're equivalent, but for Oracle to recognize that they're logically equivalent means they have to do some parsing. The whole point is to avoid the parse with a hash. So that's just the thing to remember. And another point to make to your Java developers and JavaScript developers is that if you let me write the SQL and put it inside a PL SQL API, and I would really emphasize over and over again to them, I'm going to write APIs for you. In fact, don't even mention PL SQL. I've got this great language to expose SQL through an API. It's super simple. It's even simpler than JavaScript, and you wouldn't mind it being simpler than JavaScript. You know, they write enormous amounts of that code. They might actually say, give it to me now. And one of the side effects, the benefits, is that you don't have to worry about these minor differences in the way that people are writing those SQL statements. And it doesn't take much of a difference. Okay.
And if I've followed this, if I can follow my own thoughts correctly, you're not too far from producing the report from the scope data, where you identify a set of SQL statements who have in common the same set of tables and the same set of columns.
Right, so you
It's
could...
just enough to prompt the author to think about that.
I think what you're saying, Brent, so let me go back to my example now. So in this very simple SQL statement, I'm simply saying find grouping by SQL ID and text, find everything having a count greater than 1. So it's looking for duplications of the text, canonicalized repetitions. Okay? Now you might say that's okay because we don't mind having the same select. You might look at the list and say most of these are fine, they're just this basic select into record and whatever. Some of them might say, wow, that's in 16 places, that 25-page long. Anyway, you get the idea. Now I think what Bryn was also saying is that you could do something much more elaborate instead of this exact match. You could say group together the SQL statements that have the same set of dependencies. Here are 15 queries that both go against the same 3 tables and 16 columns across those tables. Yeah?
They might be usefully different, but
Exactly.
thinking about it.
Right, so this is a very narrow scan, and if somebody wants to write that other SQL statement for me, I'd be happy to add it to the library. But you're right, so I'm certainly just...
Chris will do that before breakfast.
That's true. I've got one of the really great things about building a team to evangelize Oracle databases, I have, among other things, Chris and Connor, who know so much more about Oracle database and SQL than I do. So when I have a problem now, they do it. Dan is great on Apex and JavaScript. Dan, I need some help in my Apex application. It's really, really nice. You should get your own team and specifically design it to fill in the gaps of your knowledge. It's delightful. So yes, we're just touching the surface. And I will point you to at least one of the utilities that I think goes pretty deep and can help you in a lot of ways. So has into bulk, does a bulk collect into. Here's an example of finding dynamic SQL statements. So look for any of the statements that have execute immediate or open. Now, of course, here's an example where you could say, well, no big deal. I can write a query against all source that finds examples or instances of execute immediate. But of course, what you can't take into account are things like I decided to put a comment between execute and immediate, or they're on different lines and so on and so forth. You avoid all that sort of nonsense. Kim?
You look there for a type open. Open can both be used for the static SQL and dynamic SQL. Is there a way to distinguish between those two?
So open, you can open a cursor, and you can open cursor 4, which is dynamic SQL. And is there a way to distinguish between the two? I imagine there is. I haven't.
Open cursor 4, then you can write static SQL.
Right.
Or you can use open cursor 4 with a string that's dynamic SQL.
So,
Both open cursor 4.
yeah, I think that you would be able to. So first of all, I assume, though I haven't built an example of this and checked the contents of the statement's view, but if it's an open 4 with a static select statement, then you'll be picking up sub-elements in your view for specific tables and views and so forth. Open for a string will not have anything under it.
Exactly.
So that should be the way to distinguish between those two. Yeah. And to some extent, it's a discovery process. And I've been discovering things with Ron, who's the developer on PL-Scope, because sometimes I can't figure out how to write it. And he'll say, here's how you write it. Sometimes he'll say, oh, excellent. We have to work on that one. And then we see it patched in a future release. So undoubtedly, if you decide to go exploring, you might run into some puzzling moments, and just let me know, or no, let Bryn know, and he'll pass it along to the team, or log a bug, or something. In addition, so I thought I had, yes, conclusions. Finishing up a bit early, let's see. Back I go. So no doubt, PL-Scope gives you a visibility into your code that was never available before. It's true that you are mostly left to write the work, to do the work yourself, but that'll change over time. The big deal with 12.2, analysis of SQL, and again, even if you don't have 12.2 and you won't have it anytime soon, you might want to explore, just start exploring using this functionality. Load your code into a 12.2 database of your own and check it out. In terms of resources, we'll take a look at some more of the scripts that are out there. Of course, check out the database development guide where PL-Scope is documented. I've got a number of blog posts on PL-Scope, including the latest one was on finding select statements that have functions in them, your user-defined functions in them. And the last one I want to point you to is Philippe Salvesberg, who loves to write utilities, open source utilities for the community, and you should check it out. Let's, in fact, go to this one, because he seems to have an awful lot of time on his hands. And I appreciate it greatly. So one of the projects I started probably 2 years ago is called...
He uses some of it to get on my case.
Have any of you heard of Adgen? So Adgen is a project I started up on the OTN community site a couple of years ago, and it's been, the community is running with it. And it's Oracle Data Dictionary Generator. And it's an effort to build a fairly abstracted, generalized generator utility. So basically, you build a script or a template, you point it to a table, and it generates out code for all the columns in the table and so forth. If you want to generate table APIs or transaction APIs. And Philippe built a SQL Developer plugin that will help you use this inside SQL Developer. So check out Adgen if you like the idea of doing code generation.
When you finish and there's no rush, can I make a request?
You don't want to do it now? You want? Well, just remind me. Sure. Okay. Okay, thanks. And the latest thing Philippe has been working on is PL-Scope utils. And it looks like a really detailed, useful utility that creates a set of views and a set of packages that will allow you to ask some really interesting, in-depth questions about PL scope or about your code. And essentially, you'll probably never query from all identifiers or all statements directly, but instead use these views that he's built on top of that. So I encourage you to check it out. I've really just begun to take a look around. So what I've done in addition to the live SQL scripts, and again, just search on scope or PL scope, unless you want to see Kim's Kscope 17 examples. So finding duplicate SQL statements, invocations of package subprograms, and so on and so forth. Right, in SQL Developer, I'm starting to build out a set of reports. So how many of you use the SQL Developer reports functionality? I used to do that too. Now I'm doing user reports. So I built my own user-defined set of reports, PL scope analysis, and I can say find all SQL statements with hints, pick my schema. Hopefully we're still connected. And it didn't find anything. Oh, that's right, I didn't use hints. Let's see. So find SQL statements with user-defined functions. There you go. So the bottom line is that you can build, or you can use mine. What I'm planning on doing is at some point elaborating out a fuller set of reports. I'll export it as an XML document, and you can just import it into your SQL Developer environment. And there you go. You've got a set of reports that you can run. And then I'm sure there are many more features in SQL Developer that let you package those up into a process you can run every night and generate output and send it to you via email, all those wonderful things that I'm sure Jeff will tell you about SQL Developer being able to do. And this should make it a lot easier to start leveraging this feature. Questions?
So, if I heard you right, it doesn't write these views until you turn it on in SQL Developer with auto session or whatever. So suppose I inherit an application with, say, 100,000 lines of code. How do I quickly populate all these views to find all the stuff I don't like?
So you turn on PL scope and you recompile the program units. And you could do that.
Recompile everything?
Right. Now, recompile schema, I don't use it that often. I think that only recompiles invalid program units, doesn't it?
Well, hang on a minute.
If you compile all,
Okay.
all packages.
What? No. You need to write a program who's going to discover the PL scope settings for each unit of interest in your universe. If you want to do it most economically, but if you don't want to do that, you can just assume you'll brute force do everything. But the only way you can change the value of the setting is with an alter state. So you'd be writing alter, you'd be generating mechanically from a query, alter my unit. You might have the word, alter my unit, compile. You may or may not have the word body according to what you found out that's easy to do. Then you have to say, PL scope settings, blah, 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 and sadly doubling up your quotes and all that malarkey at this point. Reuse settings so that you don't upset any of the other settings. And you just plow through that. And the only way you could achieve the change of the setting value that you wanted would be with the alter statement. Compile. So you've compiled already. There is no space in that account to ask about compiling a schema or whatever. Just doing the alters you need. So
here's the view.
That's it.
I think so. I'll say it with an example or with the specific view. So user PL SQL object settings are all PL SQL object settings. You can query from that view to find out all the program units that do not have PL SQL scope settings set to what you want it to be. And then for each one of those that it finds, you generate out a piece of code that alters that unit to the settings you want. This would all be through dynamic SQL, execute immediate. And then you would compile that program unit reusing the settings in that session at that point for that unit.
Or just brute force it by not bothering to find out what the present is.
And just do them all.
But you'd still have to generate the alters mechanically.
Okay, thanks.
Thanks.
Other questions? Yes?
This might be a little off topic, but
far as like the API, the PL/SQL API, what is the best resource to kind of get my head around best practice for that?
So I had talked about using PL/SQL as an API language, and what's the best resource to get your head around that? Well, I suggest that you go to the PL/SQL and EBR blog, which I think is available right here. Isn't it here? Yeah, sorry. So this is Bryn's blog, and then you will find on this blog why use, where'd you go? Why use PL/SQL?
I'm frustrated that the bureaucrats changed the whole system for these blogs and things moved around a bit.
There it is. We found it. So Bryn wrote a white paper on that basically puts together a very comprehensive argument for the strategic advantages of using PL/SQL to, among other things, build this kind of API around your data. So that would be the best place to start. And tomorrow morning, he's doing a deep dive with Tone Kupelars.
Well, Tone is doing the whole talk.
Okay.
9 a.m.
So Tone's doing a talk on essentially the thick database paradigm. And I encourage you, if you're going to still be here, to attend that. And you'll get a lot more insights and give you a lot to run with. Bryn, you wanted to say something?
Yes.
Would you want to come up and use the mic so it gets recorded?
Right. I feel I have to make a kind of Thanks. Sure. I feel I have to make a kind of excuse in a way. You know, the Oracle Corporation, I mean, now the database development group has teams and so on, you know, and they all report up somewhere, and it's hard for this team to make that team do something unless you've all been in that situation. And our charter in the team I'm part of, and that's called the PL/SQL team, is the basic syntax and semantics of PL/SQL and things to do with compilation. This is clearly a part of compilation. During compilation, all this information is known and we work out how to represent it and so on. And to some extent, we do tools of a kind, like that util call stack and so on. But they are absolutely tools that some programmer can use then for good effect. And you saw examples of that. And noticeably what you saw here was a kind of query-oriented exploration. Find me all that have this property. There's another type of thing, and that's just browsing around. And slightly off topic, but similar, it's on the general point that we're missing the comfortable exposure of so much that we've done in our team because a certain man named Jeff is not quite powerful enough to influence Chris Rice's crowd of engineers to stop fussing about Oracle Cloud and all that lot and the future of the corporation and
Bryn's the CEO.
do things for us. But we've also got code coverage, you know, which discovers which parts of your code got touched or not in a present experiment. And it's most easy to make sense of that if you just color up your source text. And all we do is populate some views, very much the moral equivalent of that. And then, simple matter of programming to join with this and that and on and on and on and march along there, line and column and so on, and put in a few tags and put it up in a browser. Anyone can do that in their sleep. I did do it, not exactly in my sleep, but it was doable, but I was typing and typing all the time. It got there in the end, but I've just got some ad hoc thing on the side. And that's just an example. But I can visualize right there in SQL Developer itself. I won't say any more about code coverage, but I could. But now for today's topic, just a slightly visually cued representation of your source code where the colors represent hot items, namely the identifiers, right? And then if you have an identifier that's clickable, then the question is where would you go when you click it? And there's more than one place, but you might go, if it's a usage of some kind, to its definition. Or you might go, if it's a usage of some kind, to the next usage. I tried to get Sabine Heimsath to Spark some interest in that and go home and write it before breakfast. But it has to be specced up a bit. But anyone such as you who felt they needed a hobby could, you know, if you start to think about this, you can soon start to think what would be good to have and then start to sort of take some baby steps. If anyone isn't an ace and wants to be one, that would be the kind of way you get one close. So there's two possible approaches to getting some progress in this space. One is full-bore community effort, and like Philip's doing, you know, who is already an ace, by the way. He's the top tier ace, isn't he, as I recall? I believe so. But, you know, the other approach is to just keep on and keep on and keep on in all media available, putting pressure on the SQL developer team to get some modern exposure of our stuff. So there's two things just thoughts to sow. Sorry if it's disloyal. Not quite
Extremely
right.
disloyal of you. Actually, probably the best path to getting some sort of UI in SQL Developer for PL Scope would be to download Philippe's utility, try it out, and say, Philippe, wow. Now, if you could also build us a plugin to SQL, because he does this, he knows how to build plugins to SQL Developer. He'll probably get it in faster than any other way. And by the way, in case you didn't know this, Thomas Kurian, who's the president of Oracle and the head of product development, was the PL SQL product manager long, long ago. So
I'm on the fast.
we have great aspirations for Bryn here. Thank you all for attending. I hope you had a great week and you'll have a fine party tonight. Thanks.